Hey guys, what's up? Welcome back to our class, Statistical Methods. My goodness, we are almost done. Can't believe that, can't believe how far we've come, where we are. It's crazy. I just want to do a little review today. Want to actually maybe ask you guys some questions. Maybe you guys ask me some questions before we really get into this old exam that I just pulled up here. I've never really done this. This is kind of unprecedented. I've never done an old exam live for people before. So thought I'd do that, just try it out. Don't expect this to be exactly like the exam. This is just a way to test yourself. If you can do these problems, then you're in a good spot in that you should be able to do things you haven't seen before. So that's kind of how the exam's going to go. So before we do this, I'll just kind of pause and wait for any questions that you guys have. Do you have any questions? Because I want to answer your questions first. Like if you have questions or something specific that you want to go over, we can go over that first, and then we'll move on to this exam sheets. So let me know. I'll just kind of take a pause, check out the chat, see if you guys have any questions you want to go over first. I've got a lively bunch of students outside, so that's exciting. But you may hear like some background noise. Hopefully, it's not too bad, but just bear that in mind. I'll try to be sure that everything's clear. Let's see. Eric says, could you go over an example of an exponential distribution problem? Yeah, I think actually there may be one on here, right here. It says let x denote the time between detections of a particle with a Geiger counter and assume that x has an exponential distribution with lambda equals 1.4 minutes. Find the probability that a particle is detected within 30 seconds. Okay, so what's our distribution if lambda is 1.4 minutes? Then what is our distribution f of x? Our exponential distribution is lambda e to the negative lambda x and 0 otherwise. So that's for x greater or equal to 0. Yeah, and then we'll go over Derek's question here. It's a percentile question from the homework. We'll check that out in just a minute. So definitely. So the exponential distribution looks something like this. Lambda e to the negative lambda x. And part A says, what is the probability that a particle is detected within the first 30 seconds? So part A says, find the probability that x, the time of detection, so less than or equal to 0.5 minutes. So 30 seconds is the same as 0.5 minutes. And so, let's see. Yes, and we'll also go over examples with marginal PDFs. Let's see, actually I think this should be 1 over minutes here for this lambda, just a typo. So lambda is 1 over 4, or 1.4 inverse minutes, we should say. That way the lambda makes sense. And this is going to be integral from 0 to 0.5, 1.4 e to the negative 1.4x dx, which is going to be negative e to the negative 1.4x from 0 to 0.5. And we plug that in, we get negative e to the negative 1.4 times 0.5 minus negative e to the 0, which turns out to be 1 minus e to the negative. See, 1.4 divided by 2 is going to be negative 0.7. And crunch that in our calculator. I don't have the solutions here. I don't see any solutions anywhere that I could find, so I'm just going to be working this by hand without any solutions. So I get 0.5034. We'll round it to 1 right there. Well, it's not rounded, it's actually a 4 at the next decimal place, so I just leave it as a 1. So there's a 50% chance, or the 50% of the time, you'll detect a particle within 30 seconds of turning on your detector. So that's good question. Good question. So I told you lambda was 1.4 already, and so actually the unit should have been inverse minutes. That's a great question. So 1 over lambda is the expected value. And so the expected value here is 1 over 1.4. And that would be 0.71 minutes. In this case, it would be 0.71 minutes. So this was actually a typo. I think I corrected it on the exam that I actually gave the students. So this is actually inverse minutes right here. Good question. That's a really good question, actually, because in 242, we teach you a different way. When we go over this in calculus, we teach you that lambda is the expected value, where here lambda is 1 over the expected value. All right, so let's see. Part B says, suppose you have waited for 30 minutes without detecting a particle. Calculate the probability that no particle is detected in the next 30 seconds. So part B says, suppose you have waited for 30 minutes. So probability that x greater than 0.5 given 30, x is greater than 30. Sorry. 30 plus 0.5 given that x is greater than 30. All right, good question. So let's hammer this out. F of x is equal to lambda e to the negative lambda x, where expected value of x is 1 over lambda. So I could give you lambda directly, and that's what happened in this problem. Lambda was given in inverse minutes. Or we could give you the average time is 0.71 minutes. That would tell us that lambda would be 1 over 0.71, which would be 1.4. So you could be given lambda directly, like I gave you in this problem. Lambda was given as 1.4. Or we could give you the average time is 0.71 minutes, or 1 minute, or whatever it is. Then lambda is 1 over the average. So lambda equals 1 over the average time, or just the expected value. Does that kind of clear up anything, Eric and Josh? I know that was kind of related to both of your questions. So lambda is 1 over the average. So 1 over the average. Okay, sweet. Now, the second part says, suppose you have waited for 30 minutes without detecting a particle. Calculate the probability that no particle is detected in the next 30 seconds. Now, memoryless property. Memoryless property says it doesn't matter how long you've waited. The probability is not going to change if you've waited 30 minutes or an hour. The probability of not detecting a particle in the next 0.5 minutes is the same. So probability of x greater than 30 plus 0.5 given x greater than 30 is actually equal to the probability that x is greater than 0.5 given that x is greater than 0, which is 1 minus the probability that x is less than or equal to 0.5, which is calculated in part A, which is 1 minus 0.50341. And 1 minus 0.50341, I know could do it, is 0.49659. So that memoryless property of the exponential distribution. So it doesn't matter that you've already waited 30 minutes. You could have just started the process. It doesn't matter. It's called the memoryless property of the exponential distribution. So it doesn't matter how long you've already waited. Yeah, so lambda is 1.4 right here in the problem. And no, I see. No, it's given as lambda equals 1.4 right here in red. That's given as lambda equals 1.4. The only thing I kind of screwed up when I had this version, I think I fixed it for the actual exam, but I gave it in minutes. It's actually 1 over minutes for the units. So it's inverse minutes for the units of lambda. Usually this is time. The variable is time. So lambda is given in this problem as 1.4. In a different problem, you could be given the average time, and the average is the reciprocal of lambda, so lambda is the reciprocal of the average time, or the average value for the exponential distribution. Then you would have to take a reciprocal. But here it's given directly as 1.4. Does that help, Bradford? Yes, you could go straight. Well, it would depend on, like you could go straight here, memoryless property, and go straight here. It just so happens that I used part A by complementation, but it may not be that you can use part A, Derek. So just heads up there, that may or may not work. So these two boxes right here are because of complementation in part A. Well, part B may not actually be related to part A, so you just have to be careful. In this case, it was related to part A, so that was nice. Made the problem a little easier. Does that make sense, Derek? I want to look up the chapter 4 percentile question that you asked. Really fast, hopefully. Looks like our connections are good today. Nice and speedy. Oh, I got a little news article about Starlink. I don't know if you guys know what Starlink is. It's the like the worldwide internet service that Elon Musk is trying to put up into orbit with hundreds and thousands of satellites, and they're hoping to start beta testing in like 3 months with like their own company, personnel or whatever, and then like public beta testing in like 12 months. No, 6 months. 6 months for public beta testing. So that's exciting. Like all of the world could get potentially what they say is 1 gigabit per second download speeds from satellite internet, which is incredibly fast, which is way faster than current satellite speeds, and also like faster than a lot of, just residential, Comcast or Xfinity or whatever. So I'm trying to find the problem you're talking about. Chapter 4:15. What section? Is it like the end of chapter 4 section, like all the review problems, or is it like specific section? Supplementary? No, it can't be supplementary. Oh, no, I see. All the problems start at the beginning of chapter 4. Okay, sorry, got it. Chapter 4, number 15. Okay, got it. So Derek asks this question here. Let me write it down. It says, let X denote amount of space occupied by an article placed in a 1 cubic foot packing container the PDF of X is f of X equals 90 times x to the 8 times 1 minus x for x between 0 and 1 and 0 otherwise. Part A says graph PDF. We'll skip that. Sorry, hopefully you're not offended. I'm skipping the graphing part. Part B says, what is the probability that x is less than or equal to 0.5? Well, I won't skip part A. I will do the part that says obtain a CDF. We'll do that. Part B says find the probability x is less than or equal to 0.5. Part C says using CDF find probability that 0.25 less than x less than or equal to 0.5 and probability 0.25 less than or equal to x less than or equal to 0.5. And then part D, what is the 75th percentile? So what is the 75th percentile? All right, so this problem says obtain the CDF. It does say graph the PDF and the CDF, but I'm going to skip the graphing part. Part B says find the probability x is less than 0.5 or less than or equal to 0.5 using CDF. Part C, find probability that x is strictly greater than 0.25 but less than or equal to 0.5. And then the next part says find greater or equal to 0.25, less than or equal to 0.5. And then what is the 75th percentile? See, if I got this right, you said, can you work through part D? Okay. So, let's see. Going to put this up here. Corner. The solution. Part A, find the CDF. Well, capital F of X is going to be equal to It's going to be 0 for x less than 0. So we're going to definitely be 0 there. We're definitely going to be 1 after we go past 1. Because we're not going to gain any probability because our PDF is only defined on the interval 0, 1. So I can always fill in these parts, these extreme pieces. I know the smallest part is always 0 and the largest part is always 1. Now the part in between where x is between 0 and 1, and I think actually this should be, according to the book, strict. So change that. Now the part in between, if x is between 0 and 1, I have to integrate. So capital F of x for x between 0 and 1. F of x is going to equal the integral from 0 to x, f of t dt, which is going to be integral from 0 to x, 90 x to the 8, 1 minus x dx. And probably the best thing to do for this integration is to say that this is going to be 90 times the integral from, oh, what should I say? I should say a different variable here, t to the 8, 1 minus t dt. So I'm going to pull out the 90 from the integral 0 to x, and then t to the 8 minus t to the 9 dt. And that is going to be, let's see, 90 times 1 over 9 t to the 9 minus 1 over 10 t to the 10 from 0 to x. Now we can reduce that. Let's see, we get 10 times x to the 9 minus 9 x to the 10. So that's our CDF when we're in the interval 0, 1. So 10 x to the 9 minus 9 x to the 10. So that would be our CDF, part A. Questions? All right. Part B says find probability x is less than 0.5. So probability that x is less than or equal to 0.5 is f of 0.5, which is going to be 10 times 0.5 to the 9 minus 9 times 0.5 to the 10. So that's 10 over 512 minus 9 over 1024. And that turns out to be 10 over 512 minus 9 over 1024. And I put that in a, I guess I'll leave it as a decimal, 0.01074. And that is rounded. Well, it's not rounded. The 4, the next digit was 2, so I just left it as a 4. Could x greater or equal to 1 be just equals 1? Trying to interpret Josh's question. Could x greater or equal to 1 be just... yes. Yes, so I see what you mean. We could change this to an equal sign here and eliminate that equal sign right there. That is possible, yes. It's a good question. It could be just greater than, yes. Yes, I see. Yes, you're right. Just greater than. Let's see, part C said find the probability of greater than 0.25 but less than or equal to 0.5. Well, that's actually going to be, for continuous, it doesn't matter. We just do f of 0.5 minus f of 0.25. And we already know f of 5, or 0.5, so that's 0.01074 minus, and now f of 0.25, I got to punch that into my calculator. Let's see, I'm going to plug that in directly as like 10 times 1 over 4 to the 9 minus 9 times 1 over 4 to the 10. Be super careful to put the right things in parentheses. And that's not a good, like, pretty number. Let's see what happens if I can fraction it. No fraction. So it's like 0.00000295664. So I'm going to do 0.01074 minus my answer, and I get 0.01071. And the next part is not going to change because it's continuous. The equality doesn't change the answer, so it's still going to be 0.01071. Remember, for discrete, we made such a big deal about equal signs or not equal signs. Strict greater than, strict less than. For continuous, it's going to be the same value. So, since continuous random variable, the integral, if you include the bound or don't include the bound, the integral is still going to go from 0.25 to 0.5. There's no area under a single point. So, all right, part A, B, C, we're done. Part D, find the 75th percentile. What's the 75th percentile? So D says 75th percentile. Let's see. That means we want 0.75 less than this value. So f of x, call it star, should be equal to 0.75. So the area to the left of this x value needs to be 0.75. What should we round to on the test? Probably, I think I'm going to say round to 5 decimal places if appropriate. Like if you have more than 5 decimal places, I want you to round to that. Otherwise, just keep all of your decimal places. So if you have 2 decimal places, don't round anything. But 5 or more, round to the 5th decimal place. I think that'll be my instruction for the exam. All right, so now this is going to be not a lot of fun to do, but maybe 10x star to the 9 minus 9 x star to the 10 equals 0.75. How in the world are we supposed to get that value? Let's see. Could do factor out x to the 9, x star to the 9 times 10 minus 9x star equals 0.75. How do you get that x value? Some kind of nonlinear equation right here. Maybe they're talking about graphically. What is the 71st percentile of the distribution? Maybe we should graph this thing. Let me pull up a graph and try to estimate this percentile. So let's pull up a graph of this function. And let's make sure I put the right function in. So let's graph this thing from